Hello everyone again and welcome to this particular space, and it's truly a pleasure to actually have you all again. And please, before we dive into this particular video, don't forget to grab your notes and write the bell work for today, which is as follows. We need to build on what we talked about on our previous video, which involves angles. We talked about angles being when two lines they meet at a point, the space between the two lines when they meet at a point, which is the intersecting point, that space is called angle. We talked about that angles can be determined, one, by using a particular device called a protractor, and two, the unit of measuring the angle or the space between two lines when they intersect at a point is called, in this case, degrees. And so in this particular video, we're going to build on that. We're going to look at how we're going to check out when two lines they meet or when two lines they don't meet. And this is where first we need to look at the lesson, and the lesson for today is to look at parallel lines versus and perpendicular lines. And our goal, take note, is to show that hey, we do know how to define and identify parallel lines and that of perpendicular lines. So please don't forget to write this down on your notes, and while you're writing that down, I want you to pause this video a little bit and look at these two particular diagrams. This diagram on the left, which shows a blue line that is vertical and the orange line which is horizontal, and the difference between this particular relationship and that of this relationship between the blue line and the orange line. So once you grab your pen, you write down these particular differences on your notes. We are going to actually now talk about the differences. So first observation is this. We see that for the first diagram here, we have our specific blue line to be a vertical line. And so when you highlight it or write it down here, you write vertical line, and the vertical line is touching a horizontal line. And horizontal line, when they do touch at a point which is considered in this case to be called the point of intersect, we can then measure specific intersect. We can then measure specific things about this particular point where they meet, which is in this case the space that these two lines actually span in that particular point. And so when you grab your particular device, which in this case is called a protractor, and you check the measurement, what we see is that the space between the two lines when they meet at a point where you align the vertical line on the protractor to that of the blue line, and the horizontal line you align it properly with that of the orange line, we see that the measurement is indeed 90 degrees. So the space between the two lines is measured in this case here to be equal to 90 degrees. So that is one thing to keep in mind. And how is this on the left side here different from that of the right side? The right side, what we see is that these two lines, they are pointing or they are aligned in the same direction, which means that they will never meet, which means as well that these two lines, as long as they are in the same direction, no matter how you extend these lines further into the future, you will never actually see these lines meet at a point. And a way to prove that is by using your device, which is a protractor, and you drag it and see what angle the individual lines make. And you see here that the individual lines, they have the same angle in terms of how they are positioned on the paper. And you see that the angle is from 0 to 180. So indeed, the orange line and the blue line, they both have the same angle, which is 180 degree, but they never meet. So that is the big difference in terms of both of them. And so in conclusion, we consider this particular relationship here where these two lines, they never meet to be called, in this case, parallel lines. And parallel lines, they are two lines that are in the same direction and there is no point of intersect. However, on the other side, intersect. However, on the other side, which is to define a perpendicular lines, which means we have one line either pointing this way and the other line pointing the other way, and what we see is that it can be positioned however you want. It can be this way, it can be however you want, this way as well. Once you measure the space between these two lines where they meet, which is in this case they meet at a point, you measure it to see that indeed the space here is 90 degrees, and the same thing is applicable in here, 90 degrees, and what we see as well here is 90 degrees. So always perpendicular lines, when they meet, they form an angle that is 90 degrees. That is what you need to take note right here. However, for perpendicular lines, they don't meet at a point, which means that there is no angle. However, the individual lines, they share the same angle of incline. So which means that whenever you have either a line that is pointing this way or pointing this way, you can have three lines pointing in the same direction. You can have four lines pointing as well in the same direction, as long as they never meet individually in here as a group, and this one here as a group, and this one here as a group. As long as they don't meet, that means that they will never intersect, and that means that they are parallel to each other. And so in this case here, you can say that the angle in line A is equal to that of the angle in line B. So in here we'll just make our line A, we like that's LA and LB. So if you have two lines, one labeled as 1A and one as 1B, the angle number, which in this case if it's 20 degrees individually, the other angle for that other line will be 20 degrees. And so therefore that tells us that they'll continue to be in that same position, but they will never meet and they'll be distant from each other. So in this case here, what symbols do we use to represent a parallel line versus that of a perpendicular line? So a parallel line, if you have in this case two lines, we have one line here and we have another line here. Let's let this line to be line A and this is line B. This line here, since they are not touching even now or in the future, they never meet at a point. This is symbolized as arrows that are pointing in the same direction. Therefore, in sentence form, we can say that line A is stroke stroke. Two stroke lines are parallel, that is represented as the two stroke lines, to that of line B. So you can say here that line A is parallel to line B. However, on the other side here, when looking at perpendicular lines, let's say, take for example, you have this line and you have another line here, and you see here that the measurement of the angle from this particular point to this particular point, let's make this line here horizontal one to be line A and this is line B. The angle here, which is 90 degrees, as what we stated right here, is symbolized as this little square in the particular junction where these two lines they meet. And so therefore we have line A to be perpendicular, which is represented as the T symbol that is flipped upside down to that of line B. So you can also write it as line A perpendicular to line B. And so perpendicular means you have this particular symbol, which is the T flipped upside down, while parallel is symbolized as the two stroke lines that are shown in here. So example in this particular case is when you're given lines that are in this particular format, and here you've asked to tell us the relationships between the lines in terms of which ones are parallel versus which ones are perpendicular. So that's what this question is asking, and you're going to come across this question on your activity in your Apara workspace, where you're going to be having questions, and so keep this in mind when dealing with those questions. And so in this particular case, we have various particular lines, and we're going to address these lines by breaking them into two groups. So one group here is parallel lines, and this is represented as what? Two stroke lines. And perpendicular lines that are represented in this case, if they're perpendicular, as this T flipped upside down. So therefore in this case, what we see is that this particular line, blue, is noticed to be perpendicular to the black line, and you can confirm that by actually dragging this over and seeing it for yourself, and voila, indeed it is perpendicular, which means that the blue line is perpendicular to the black line. So blue is perpendicular to the black line, and you can show this relationship by putting this particular square box right there. Another one again you notice is this particular shape right here, where this line is noticed, which is the orange one, to be perpendicular as well to that of the red line. And you can actually look at it in terms of, hey, the distance from this space, specifically from this particular orange line to the red line. And so if you count from this angle all the way to this tick point right here, you should count a total of 90. So therefore, indeed, the specific orange line, which we're going to write right here, is perpendicular to that of the red line. And another one here as well is, notice the same thing we did with the orange and red line is what we're doing with the orange and green line. And so therefore, the orange is as well perpendicular to that of the specific green line. And so you can show the symbols of those particular line relationships as perpendicular by showing the specific box right here, or the square at that particular junction where the two lines they meet. So keep that in mind. So you think that is it? No, not really. There's still one more relationship that we need to take care of, and in this particular case we have the two lines here, which are the green line and the red line. Although you don't notice, but once you look at the angle inclination clearly, we see that there is some relationship going on. They don't touch each other. Take note of that. That is one. And two is that the angle of incline is the same. It's the same in the sense that looking at the angle of incline of the green line only, we see that it is around, in this case here, close to 44 degrees right here. And if we check that as well for the red line, we should hope, if you line it up properly, it should be as well around 44 degrees. So in this case, they both incline at the same angle, which means they fall at the same angle, 44 degrees, but the two lines, they never meet at a point. So therefore, they are parallel to each other. So the green line is indeed parallel to the red line. And so that is it. That is how you're able to categorize lines based on their relationship as either parallel, in this case right here, and perpendicular. Take note that perpendicular means that two lines or more lines, they meet at a point, and the point where they meet is actually forming an angle that is 90 degrees to each other. However, for parallel lines, they never meet, which means that they only incline individually but with the same amount of incline or the same amount of fall that it looks like, either horizontal, vertically, or inclined at this particular position. So they must be in that particular format in order for them to not touch each other, and they are considered to be parallel. So that's about it for this particular video. Please make sure you go through the practice questions 2 and also the inquiry angle parts 2, and see you all on the next one. Please don't forget to ask questions on Google Meet. By that way we can talk more in depth about this. By that way I can talk to you soon. Stay smart as always and believe in yourselves.